So today's lesson we're going to talk about Venn diagrams and how that can be used for making counting easier. And we're going to understand when to use Venn diagrams and how we make those counting. And the idea of a Venn diagram is to visually sort sets of data where there may be some overlapping. So the idea here is I could have two things that are happening here and there's some overlap there. And what we call that overlap, we call that the union, or sorry, the intersection of those sets. So those are the common things that you see that are like. Another way of thinking about this in an English setting is if I was going to compare and contrast two novels, so if I have novel A and novel B, all right, this area would be area that is common to both sets. That's another way of saying it. So if I was doing a novel comparison between two novels, the overlap would go there. We use the same thing in math and science, a whole bunch of different things to be able to understand what's going on. When we talk about, when we create Venn diagrams, we use data given to us in sets. Sets are groups of distinct objects. And sometimes these items have these things are like curly brackets to put the elements into. So these could be it could be, doesn't have to be numbers, it could be objects, it could be ideas, whatever it is. And these curly brackets just outline that set, and we're going to talk more about that as we go into other sets of data down the road. The idea of elements is basically what's inside it. So the 2, 3, 5, 7, 11 is part of this set. So it's not too crazy. And this A here is just the label for the name of the set. All right, it's usually a letter. It's not a big deal at this moment. So sometimes all the elements in one set fit into the criteria of another set. This is called a subset. So it's a smaller set. So if I was looking at O as being everyone that lives in Ontario and C everyone lives in Canada, we can say that O is a subset of C. And you can look at that and say, I can draw a little picture of this. See if this was Canada. All right. Here's my O, which would be Ontario. So that subset, I spelled Ontario wrong, is inside that entire set. So this symbol here is called a subset. Likewise, if I have sub E is 1, 3, 5, 7, 9, and F is 2, 4, 6, 8, if I take the union of those, so if I combine F and E, that gives us all the letters. So, for example, these are odd, these are even. If we combine them, they're all together. So this is what's called the union. And the symbol here, U, says union. In general, the union of two sets, A and B, is a set of the elements which are in either set donated by that. Note that they can never be repeats. And we're going to show you what that means in a second. Sometimes we want to have two more sets and see what's in common. And that's kind of what we're talking about above. This is called the intersection. All right, so we have two words that we're looking at, is union and intersection. So if I wanted to find the intersection, and that's what that symbol is, intersection, we want to know what's in common in both sets. So if I look at 1, 3, 5, 7, 9, and 1, 4, 8, 9, 10, we look at it and say, well, 1 is common in both, and 9 is common in both. So those are the intersection. Okay, so in general, the intersection of two sets A and B is in the set sandwich, which are both sets donated by that. So they have to be both. And then again, there can't be any in repeats. So the question is, that's the knowledge. How do we put this into practice? Okay, how do we put this in practice? So before we look at the top part of that page, I'm going to look down here at example 2. Originally, there's 100 people wanting to be part of the school's musical. A sheet was set up for people to sign up to be on stage or behind the scenes. There were 65 people who signed the sheet wanting to be on stage. On stage. Then there's 23 people signed up to be behind the scenes. But there's 12 people that signed up for both. And this is a very simplistic example of this. And there's different ways of organizing this counting that makes it easier. So when we talk about organizing this data, all right, the first thing we want to look at is part A, or we want to know what's common in both. So what's the intersection? And you can see here that 12 people signed up for both parts. So there's got to be 12 people in that part. And let's see here. Let's say we have this being the on stage. So let's call O as on stage and B being behind the scenes. All right. So we know that in this blue circle that we're going to draw of on stage, there was 65 people that had to be on stage. So there's 65 people inside that blue circle. However, there's 12 that's already been accounted for. So this is where the overlap we want to take out. So in this case, we're going to subtract out that overlap. So if I take 65 minus 12, there was 353 that are only want to be on stage. Likewise, behind the scenes, there was 23 people that signed up for it. However, all right, 12 of wanted to do both. So we have to subtract off the parts that are not added into that. So this is 11 that are only on stage. And we look at this, we can say to ourselves, well, how many people are there? All right, so our thinking here is we find the common theme, the intersection. And then we work outwards to find what is left over. Okay. The other thing we haven't dealt with is this 100 people. Well, there's 100 people wanting to be in part of the musical. And as you know, some people like to say that they're interested in something, but never really sign up for something. So if we look at this, there's got to be 100 total people in this whole scenario. So the question is, how many people did not sign up? Well, we knew that there was 12 to start, did both. We had 53 that only wanted to be on stage, and 11 to be behind the scenes. This is supposed to be behind the scenes, my fault. So we know that these pieces are mutually exclusive. They're totally separate. Either they're doing both or one or the other, but they're not connected. So what we can do is we can take that 100 people and subtract off the items that are left. So now I can take 100 minus 53 minus 12 minus 11. So I can take 100 minus 53 minus 12 minus 11. I know that there's 24 that did not sign up. All right, and by completing that Venn diagram, we can answer a lot of these questions. Well, how many people signed up to only work behind the scenes? All right, we know that's 11 because we've labeled our graphs, labeled our Venn diagrams. This is only behind the scenes. This is behind the scenes. This is only. These 12 wanted to do both. How many people signed up only to be on stage? 53, because there's not any overlap. There's just one piece of the circle there. How many people signed up to be on stage or behind the scenes? Well, it could be the total of those three things. So if I was looking at part C, and I'll do part C down here, it's actually 53 plus 12 plus 11. And that adds up to 76. All right, and the D part we just kind of did there, the 100 minus the 76, which was 24, that did not sign up for anything. Okay, so part C was asking for the union of the two sets. So another way of saying that. All right, so it's or, so there's 53 or 11 did that or the total. Okay, and that's kind of the same thing as this principle of inclusion or exclusion. For the sets of A and B, the total number of elements in either A or B kind of works the same way, and I'll show you kind of, if I was using that example down here, well, in A, technically there was 65 people, all right, plus the 23 people, minus the intersection, so the ones that did both. And if I did that same work, okay, 65 plus 23 minus 12, I get the same number. So when you're doing this work, you can do this work or the work up here. It doesn't matter. I know when I'm teaching, I find it easier to do the whole Venn diagram and then answer the questions based on the picture. There are some people that like to use the symbols to answer the questions. Either or is totally fine. Either or is totally fine. Okay, so there's two events. All right, sometimes we have three events, and that's nothing different than what we've done already. Okay, it just has three events. We've got basketball, volleyball, and soccer. So I'm going to label B, soccer, volleyball, and soccer. And it doesn't matter the order as long as you've identified which letters represent what. So I'm going to let you read through that question, and I want you to think, when you read through that question, what I want you to do is, what is one number that is guaranteed to be from this work that can go into that diagram? So I'm going to hit pause, and I want you to think about which number goes in that, and then hit on pause to check it. Hopefully you said 2, because this is the overlap of all three circles. So if I was thinking this purple one as soccer, this green one was basketball, and this red one was volleyball. All right, those are the three 3 items overlap, we guarantee that there's that. And just like we just said above here, we find the intersection. If we went back to our thinking here, we were going to start at the intersection and then work outwards to find what's left over. Okay? And this will take some practice. This is not as straightforward. Okay? So, let's look at, there's 2 that are on all 3. So we dealt with that scenario. There's 5 that are on basketball and soccer. So if I look at my thing here, basketball and soccer is this bubble. This bubble right here is just basketball and soccer. Let's do and. All right, and we know there's 5. So if I look at that, there's got to be 5 in there, but we already have 2 here. All right, that's why that would be 3, because when we're at the end, we want to say how many people were wanting to be on the basketball and soccer team. There has to be 5 in this bubble. 2 was already accounted for. Okay, and you want to kind of work backwards. So the idea here is this is an overlap of 3, and then we're going to find these wedges. All right, so I want to know basketball and volleyball. So if I look at it, there's 7 students that are on basketball and volleyball. Well, there's got to be 7 in this bubble. So 7 minus 2, that means there has to be 5 there to make a total of 7 from the question. All right, I'm going to push pause, and I want you to tell me what has to go in that wedge. Hopefully you told me there was 6, because we know that there's 8 on the volleyball and the soccer team. Volleyball, soccer, minus the 2 that starts, that gets our 6. And sometimes leaving these calculations there gives you a reminder of what you did, how you got those answers and such. Okay, let's see what now. We have 20 people on the basketball team. So we know that there's, I'll use green here because it's a green circle. There's got to be 20 in this circle, because that's what represents basketball. Well, you have to ask yourself, how many people have already been accounted for? These 5 people, these 2 people, and these 3 people have already been accounted for. So what I'm going to do is subtract the items already in that set. So subtract 5, subtract 3, 2, subtract 3. And if I did the math, that's where the 10 comes from this. All right. If I look at the volleyball, there's 15 people that played volleyball. However, 5, 2, and 6 have already been accounted for. That's where that answer is going to go in there. So 15 subtract 5 is 10. Subtract 6 is 4. Subtract 2 is 2. And soccer, there was 22. All right. And what I want you to do is tell me which numbers. I want you to write down what numbers subtract off to figure out what goes left in that bubble. So go ahead and push pause and try it. So hopefully you said 11 was left over because this 3 was already counted, this 2 was already counted, and the 6 people have already been counted. And if I subtract those off from the original amount that I started with, that means there's 11 people left over. So try to work on this strategy by building this, and then once you build this, answering the questions becomes even better. The only other thing we haven't dealt with is the 170 students were eligible to play. Well, just like we did up here, to find out how many people were not on any teams, all right, we can do is subtract off all these entries. So I'm going to subtract 10, subtract 5, subtract 2, subtract this 2, subtract this 6, subtract this 3, and subtract that 11. All right, so I'm taking the 170 of the total people that are inside this box, and then we're looking at how many are not in those rings. So I can do 170 minus 10 minus 2 minus 2 minus 6 minus 3 minus 11. In the end, there's 136 that did not play anything. Okay, it looks messy, but the thinking there is going to help you to build those. And then you can answer any question on that sheet. How many students were not on any teams? Well, we just shown that there's 106 did not play. B, how many students played only one sport? Okay, well, if I was looking at it, one sport would be just volleyball. So this part plus is this part and plus this part. Because there's no overlap of other rings around that. There's no overlap on this one or this one or this one. How many students played only soccer and basketball? That's interesting. So only soccer and basketball. Well, first of all, we have to look at where's the soccer ring. So that's the purple one. And where's the basketball ring is this one. So it looks like it's 2 and 3, which is 5. But this word only played soccer and basketball. That means they can't play anything else. That's where that 3 is the answer, because you can't play, so not volleyball. So only soccer and basketball. So this will take a little bit of time to build. Try it. Rewind this recording and see if you can redo it. Okay? But my strategies are when you're building this, start with the intersection. So here, if I'm looking at this, I'm going to start with the middle ring there. If I have 3 sets, start with the triple overlap or intersection, or what's common in all 3, and then look at what's common in 2 of them, and then work yourself out. And that's going to help you guide this. All right, and if you're struggling with this, rewatch the tape, rewatch the recording of how you got those. All right, you got this.